Assalamu alaikum, my dear students. Happy New Year to all of you. I hope you all are doing well. This is Aisha Rehan, your instructor of computer science for the year 2020-2021. Year 2020 has passed and now we have entered a new era, 2021. So looking for a better future, and this is the high time to make resolutions, children. This is something very, very important. Whenever we start new year, you have to set your resolutions so that you have target to achieve. Once you have target to achieve, you can do better in your life. So it's better to make or maintain a diary in which you have to write that what you have to do something less in your life now, from now onwards in 2021, and more in your life in 2021. This means you have to set your boundary that which thing is right and which thing is not right for you. So in this way you can actually make your life better. So moving to business, what exactly we are going to do in computer science 2210. The most important aspect that we are going to cover now for the time being is operating system. We already have done a great deal of operating system in a last semester till interrupt and buffers. I'll be touching upon interrupt and buffers and definition of operating system right now. But what exactly we have to study in this semester is about its architecture. That is something very, very important to know. As I gave you a clear-cut example of operating system with reference to school administration, I hope you can remember it. If not, you can always go back and see your previous operating system video for references. So moving ahead, what exactly we are going to do? We are going to examine computer architecture and describe what was important in one Neumann machine that was designed by von Neumann, and we're going to study some key features of von Neumann machine, and then we will understand what exactly are registers and what are the functions of registers. So moving ahead, do you remember what exactly is an operating system? So I want you to write it in your booklet that what is an operating system. Okay, remember, do you know that I gave you example of school administration? Like everything that is going on in your school is actually operated by school administration that apparently is doing everything at the back end and is responsible for everything that's going on in your school, starting from timetable management and your course management, division of classes, and your sports timings. Everything, from tip to toe is actually administered by your school administration. In a similar manner, operating system, or we call it OS, is actually a software that communicates with the hardware and allows the program to run. Every desktop computer, may it be tablet, smartphone, it includes an operating system that provides basic functionality for the device. Okay, so I want you to take a round and examine that how many computers do you have at your place, starting from your cell phone till your desktop and your tablets. Please keep this in mind that you have to separate your customized devices, that is machines, washing machines or microwave oven, as not being operating part that is run by operating system. Why? Because it actually works in one style, that is by pressing a button it is going to do one specified task. For example, you cannot wash clothes in your microwave oven, can you? So this means it is specifically designed by embedded microprocessor to do one specific task, while operating system is the one that enables you to do variety of tasks in one go. Is it clear? So everything that is monitored, may it be application, printer, mouse, hardware, is actually administered by operating system. I hope it's a refresher. Please write the details if you have perceive what exactly is an operating system. So moving ahead, I want my children to remember all the tasks done by operating system. For example, if you talk about, let me get my gadget. So if you talk about multitasking, if you talk about multi-programming, batch processing, error handling, starting from human computer interface, everything is actually covered in your last semester, and I hope you all know what are the tasks performed by operating systems. Okay, we actually, give me 1 minute. I want my children to see this diagram critically, that how does an operating system work. Okay, so if you see it critically, because you know, you will understand that how does an operating system work. When the computer is first powered up, the initiating program are actually loaded into memory from ROM, as you can see in this picture. These programs run a checking procedure to make sure the hardware, processor, or internal memory, or any BIOS means basic input output system, are all functioning correctly. So it makes sure that whether all the processes are working correctly or not, and if no errors are detected, then the operating system is loaded into the memory. um, It is worth mentioning, as I told you before, that the simple devices with embedded microprocessor don't always have an operating system, as I give you an example a minute ago. So I hope you understand what exactly I mean to say. So this is how operating system work. So we all are ready to go ahead to study something more, something different. Before it, let's touch upon interrupt and buffers also. We also studied interrupt and buffers, and I want my children to reinforce that what happens when interrupt occurs also. So what exactly is an interrupt? It allows computer to multitask. So this means if I'm doing variety of tasks in one go, I need interrupts. While buffers are used in computers as temporary memory area, and they're essential in modern computers because hardware devices operate at much slower speeds than the processor. For example, if you're working with the printer, then buffer will actually take all the data from the printer into the buffer, and then printing will be done in one go. Okay, now are you all ready to study architecture, computer architecture? This is something very, very important to understand, that how operating system operates, or what is that magical wand actually, with the help of which this operating system performs everything in one go with fraction of a second, isn't it? So this is that person who's actually responsible for everything that you can see now. You can enjoy this life now. I want you to Google it and find who is that person. Pause the video and find. So John von Neumann was actually a Hungarian American mathematician. He was physicist, he was computer scientist, he was engineer, he was polymath, he was he had a lot of expertise in one package. Von Neumann was generally regarded as the foremost mathematician of his time, but if you actually consider your domain, he's responsible for giving us a concept of the stored program that is still in use in one way or other. Okay, the concept of the stored program is actually the same as is given by John von Neumann. So that clearly shows that when there is a will, there is a way. You can be as smart as John von Neumann was actually. So if you consider a detail, in 1945 he actually described a computer architecture for the first time, and this fundamental concept of computer science is given by von Neumann. I hope the concept is clear to you now. This is the most important model that you have to understand. Once you have a grip of understanding this von Neumann model, then you can study everything in detail in a clear concept. Okay, so if you try to understand up till now what exactly we used to do, we used to study that, I'm sorry, just give me 1 minute. Input is given, it is processed, and then output is given. Agreed? Now, Here the concept is same. In John von Neumann model, um, input is given, and this is how, I'm sorry, this is, technical glitch we have to bear with. This is how processing is done, okay, and then output is given. So we are actually going to unbox what exactly is inside that processor. Okay, so the central processing unit comprises of two important components, that is control unit and arithmetic and logical unit. It actually collaborates with memory unit and then gives you an output. Is it clear to you? So let's study. We have to understand what is this, that control unit. Okay, so I want you to tell me, what does the name implies? What is a control unit? A control unit is actually, you also call it CU, C capital and U capital, is a component of a computer's central processing unit, as I told you, that directs the operation of a processor. Okay, it tells the computer memory, arithmetic and logical unit, input and output devices, how to respond to the instructions that have been sent to the processor. Okay, so I want you to imagine that what exactly is that component. It simply tells the computer memory or arithmetical logical unit or input and output devices how to respond and what to do. So it is actually controlling everything. Okay, so then comes arithmetic and logical unit. So what is, as the name implies, arithmetic and logical unit is a part of a computer that carries out arithmetic and logical operations of a computer. Okay, every operation that's going on is actually done by ALU, all logical and arithmetic operations. And in some processor, the ALU is divided into two important units, that is AU and LU, arithmetic unit and logical unit. We are not going into detail at your level. So all you have to understand is that arithmetic and logical unit performs all arithmetic and logical operations. Okay, then you can say memory unit. It's a component of a computer system and it is used to store data, instructions and informations, and you really need memory. If you do not have memory, then you cannot carry out your processing well. It is actually a work area of a computer where the CPU stores the data and instructions. It is it is known as main memory, primary memory, internal memory, or whatever you call it. Okay, so diagrams also showing some wires. Okay, yeah, input, there's one arrow coming into this processing unit, and one output arrow going towards output devices. So we'll be discussing about these wires, that what are this, but this is also an important component of one human machine. I want you to go back to your school example so you can easily understand that which one is the control unit and what is arithmetic and logical unit and what is actually memory unit. Okay, so control unit is actually controlling each and every operation, arithmetic unit is carrying out operation, and memory unit is a working space provided. Okay, and these arrows are means of transportation. Okay, so moving ahead, what do you mean by transportation, means of transportation? So these arrows that you can see is actually a bus. Buses are circuits on the motherboard that connect the CPU to other components. There are many buses on the motherboard. We'll be discussing each and every kind of bus in detail. A bus moves instructions and data around the system. Okay, the speed of the bus is measured in megahertz. The faster the bus, the faster the data is communicated. Is it clear? So give me 1 minute please. Okay, so what we have studied so far, we have studied, let me go back. Okay, now, so all the basic concepts, what is control unit, what is ALU, what is memory unit, and what are buses. The most, why it's important to study one Neumann model, because it has given us a clear concept of stored concept. Okay, so the most important thing is that you have to understand that before 1 Neumann model, there were many examples. We had a lot of computers, but they actually did not improvise the concept of stored mechanism. This means storing for the first time, storing of data and program for the first time actually took place via 1 Neumann model. Is it clear to you? So now moving ahead. I want my students to see this diagram, sit back and just analyze what is happening. It is exactly the same what we have studied so far, but with a minor difference. There are few arrows that have become prominent because I will be explaining you buses in detail. Okay, so like the purple arrow that you can see going from a processor towards memory and input is actually an address bus. The green bus that you can see, it's two ways arrows from processor to memory and input devices and vice versa, is the data bus, and control bus is the pink one. Now I will be explaining you that what are the function of these buses in detail. Okay, so are you getting? Pause the video, go and get a glass of water. I hope the concept was not at all difficult up till now. Okay, so here comes the main concept of the buses. There are three types of bus: an address bus, data bus, control bus. Okay, buses can be unidirectional or bidirectional. So we'll be discussing about address bus and data bus and control bus in detail. But what exactly is an address bus, data bus and control bus? You have to understand it. The major difference between address bus, control bus and data bus is that address bus identifies the source or destination of data. Data bus used to carry data signals, while control bus controls the signals, okay, among devices. It is actually connection between the CPU and the main memory. Okay, I hope you get a little bit of it. With the passage of time, you will definitely get each and everything in detail. What exactly is an address bus? An address bus sends a memory address. Okay, clear? Along the bus from the CPU to the memory. To fetch, write data, the CPU needs to tell the RAM the address. Okay, so what is an address bus? It sends the memory address. Okay, what is the data bus? It sends the actual data to and from the memory. And what is the control bus? It carries commands from the CPU and status messages from other hardware devices. Commands. Is it clear to you? Here you can see, I'm sorry, this is red. Which one is the red one? Address bus. Which one is the yellow one? Data bus. And which one is the purple one? Control bus. So I will be explaining you each and every bus in detail now. Moving ahead. Let's go to address bus. Okay. The address bus carries addressing signals from the processor to the memory. Okay. To memory, I/O devices and other addressable devices around the processor. Okay. Is it clear? Control signals move out of the processor but not to it. That clearly shows it is unidirectional because it is actually carrying addressing signals from the processor to memory, I/O devices or any addressable devices. Okay. No outside devices can write into the microprocessor. So it's purely unidirectional. Is it clear? So if somebody says what is address bus, it carries addressing signals from the processor to memory and other devices, and it is unidirectional. It is unidirectional. Is it clear to everyone? Okay. So moving ahead, what is data bus? A data bus can transfer data to and from the memory of a computer or into and out of the central processing unit that acts as a device engine. A data bus can also transfer information between two computers. Okay. Data bus, also called a data path, a group of signal lines used to transmit data in parallel from one element of a computer to another. Okay, the number of lines in a group is the width of a data bus. Each line is being able of transferring one bit of information. So what do you think? Is it bidirectional or unidirectional? Yes, if you're thinking it's bidirectional, you are right. Why? Because it's actually a group of conducting wires which carries data only, so it's always bidirectional because data flow in both the directions from microprocessor to memory and input output devices, and vice versa. Okay. And what is a control bus? The control bus carries commands from the CPU and returns status signals from the devices. It is regarded as either unidirectional or bidirectional due to internal connections within the computer architecture. So what is a control bus? It carries commands from the CPU and returns status signals from the devices. Is it clear? The physical connections that actually carry control information between the CPU and other devices within the computer, right? The data bus carries actual data that is being processed, and the control bus carries signals that report the status of the various devices. I hope the concept is very, very much clear to you. If not, go back and understand. Okay, so this is actually a detailed model of a one Neumann machine, right? Now you simply get each and every component in detail. CPU also actually the most important component, the most important key factor of one Neumann machine is the concept of the registers that we'll be studying. Okay, so this is actually something that we do not know, except it we all know details about each and every component in detail, including buses also. So what are registers? I want you to sit back, relax and analyze this diagram. Okay, have you seen this diagram? Good. Now I'll be explaining you what are the registers. Here you can see, now we know all the coordination of memory along with processor and with input and output devices, and we know that we have three kind of buses: address bus, data bus and the control bus also. But you can see here registers. I'll come back to this diagram, but before it I have to make you understand what are registers and how many registers are there so far that you have to study for the time being in your class level. Okay, so what are registers? Okay, a register is something where you write, you store data, sometimes for the time being or sometimes to keep it for the reference also. So exactly this is the concept of registers in computer science. It's a high storage area and data must be represented in register before processing. Okay, operands and results must be stored in registers. For example, if computer is doing 2 plus 3, you are doing 2 plus 3 and you're getting answer 5. This means this 2 and this 3 and this 5 has to be stored in register. Okay, even operator needs to be stored in register as well. Okay, so that's what we are going to study, what exactly are registers. Okay, is the concept clear to you now? Now moving ahead, so these are built-in memory locations in processor, and they are fastest memory locations since they are present inside the central processing unit, and it can hold an instruction and memory location or data, as I told you as an example. It also used by the CPU to process, to store and to transfer data from one component of the computer architecture to another. So this is something very important. Okay, so moving ahead, here you can see that memory unit, along with memory unit you can see two registers MAR and MDR with ALU, you can see ACC, this is accumulator, and with control unit you can see PC and CIR, okay, control instruction register. We will be studying all these registers in detail. Okay, so what exactly is a program counter? Okay, the program counter holds the address of the next instruction to be executed. This means program counter is a little bit fast in counter. So if one instruction is in the process of execution, it will store another execution address. Okay, this is something you have to understand. It will be very easy for you to understand if you memorize each and every concept. If you understand each and every concept, that what is the function of which count, of which register. So program counter, it holds the address of the next instruction. It is also known as the sequence control register. Okay, I'm not going into details right now. So for the time being, you have to understand it simply holds the address of the next instruction to be executed. While memory address register, it holds the address of the memory location from which data will be read or which data will be written. Its simple example is that MAR will simply hold the address. For example, if I'm sending you a parcel, a gift, then definitely I have to store address somewhere. I have to write address somewhere, so your data will definitely go to your specified location. So this is the duty of memory address register, to hold the address from which data will be read or will be written. Both instructions and data are held in memory, so that sometimes the memory address register will hold the address of an instruction to be fetched, and sometimes it will hold the address of data to be used in an instruction. Is it clear? So all you have to understand, what is PC? It actually stores address of the next instruction. What is MAR? It stores the address of the instruction to be executed. Okay. What is MDR? Memory data register is used to temporarily store data read from or MDR written into memory. Okay. For example, the instruction LDA 1000 is placed right here to CIR, where it will be decoding. Okay children, for the timing, what you have to understand, this is only one thing, because in the next lesson I'll be explaining about these registers in detail. Okay, all you have to understand is that what exactly memory data register does is it temporarily stored data read and from the memory. Okay, CIR, the current instruction register, it contains both the operator and the operand of the current instruction. This means 2 plus 3, right? For example, machine language instructions to load the content for location 1000 into accumulator might be written LDA 1000. Okay, so all you have to understand is current instruction registers contains both the operator and the operand of the current instruction. Okay. Accumulator, also called general purpose register, and it is used for performing arithmetic and logical operations. I hope the concept is very clear to you now. Okay, so you have to understand these are actually name, some of the names are none of our business right now. Why? Because we are not studying it as a computer grade 9 student. When inshallah in future you will take computer science as your subject, then you will be studying all these register symbols in detail. All you have to understand is AC is for accumulator, IR is for instruction register, PC is for program counter. Okay. Okay, before watching this video as an end, there are few things that I would like you to do it. Okay, so like what exactly you have to write it in your booklet, things to do to be done in your booklet. Okay, so you must draw one Neumann model, this is only for your reference. If you do it, if you know all these things, that is going to be good for you. All you have to do, you must know what is CU, what is ALU, what is memory unit, what are registers, write functions of PC, MAR, MDR and CIR. Write 3 types of buses. And functions. If you're able to write these details, this means you are on the right track. Okay, if you are not able to write it, this means you have to go back, watch the lesson and write the details. Please watch the video now. Just give me 1 minute. Okay, thank you so much. Inshallah, see you in the next class. I hope you have digested everything, whatever I've said. As I told you before, if you're able to write whatever I gave it to you, this means you're on the right track. See you inshallah in the next class. Allah Hafiz.